has the age-old question of whether or not our species is unique in the cosmos finally been answered. We might be getting closer to a game-changing finding, thanks to the James Webb Space Telescope, introducing K218b, a faraway exoplanet that has recently become a focal point in the field of astrobiology, why its atmosphere contains an anomaly that the James Webb Telescope found, which may indicate the presence of life. The molecules that make up water vapor methane and the extremely rare chemical dimethyl sulfide aren't completely at random. Perhaps these are the biosignatures that have been puzzling scientists for so long. Hints that extraterrestrial life does in fact exist. Our new guardian of the galaxy, the James Webb Space Telescope, JWST, is armed with the most cutting-edge space equipment ever built. Its purpose is to peer into the unknown and maybe reframe our notion of existence. The enigmatic I-verse of K218b could be something you're prepared to explore. We depend on the telescopes of our technological wonders to sharpen our understanding of the cosmos as we travel farther into space in quest of solutions to riddles that have baffled humanity for ages. Among these, the James Webb Space Telescope stands out. We owe a great debt of gratitude to the Hubble Space Telescope for decades of providing us with breathtaking and informative photographs of the cosmos. Still, not even Hubble is without its limits. Enter the James Webb Space Telescope, a telescope whose mission is to expand our understanding of the universe through the power of light. The JWST cooling screen technology is among its most remarkable characteristics. The size of a tennis court, this multi-layered technical wonder blocks the heat of the sun, earth, and moon, making it far from an ordinary sunshade. Just how crucial is this? As a result, the telescope may be cooled to extremely low temperatures, making it more sensitive to feeble infrared signals given off by faraway stars. Exoplanets like K218b can only be studied with the use of infrared observation. Space dust can block or scatter visible light, but infrared waves can pass right through it, allowing for much better and more detailed photos. Infrared observations made possible by JWST represent not just an accomplishment, but a game changer for our understanding of faraway planets. What new information might we expect to uncover as our attention moves to K218b? The 124 light-year distance rock resides in the constellation Leo, but it's more than that. The habitable zone around a star is known as the Goldilocks zone, characterized by temperatures that are just right for liquid water to exist. K218b follows the same orbit around its parent star, K28. However, how is it different from other exoplanets that occupy comparable orbits? Scientifically speaking, K218b is a Hyzen world, not your average rocky planet. The discovery of habitable worlds with an oceanic surface and an atmosphere rich in hydrogen marks a new chapter in the quest for alien life. These planets provide environments that could be comparable to those around Earth's hydrothermal vents, which are known to be home to a wide variety of ecosystems. New information regarding K28b's atmosphere has been uncovered by the James Webb Space Telescope's recent studies. The atmosphere of this faraway planet contains a variety of gases and elements that potentially support life, or at least life as we know it. These include water vapor methane and possibly even dimethyl sulfide. The scientific community is ecstatic about the finding of these atmospheric components. The scientific community is abuzz with anticipation and conjecture as they consider these findings and what they could mean for astrobiology and the search for extraterrestrial life. The peculiar atmospheric makeup of this Hyzen world raises the intriguing possibility that it holds the key to understanding life beyond Earth. What does the future of astrobiology hold in light of its unique conditions? One of the most difficult and potentially lucrative parts of exploring extraterrestrial planets is learning about their atmospheres, the unusual atmospheric composition and distinctive habitable zone placement of K22 to 8b make it a compelling case study of how exciting and fruitful these kinds of investigations may be. A completely different cocktail is presented by K218b compared to Earth's atmosphere, which consists of trace gases nitrogen and oxygen. The hydrogen-dominated atmosphere of this exoplanet is rich with scientific mysteries as it contains trace amounts of water vapor, methane, and even dimethyl sulfide. Researching an alien planet's atmosphere from over 100 light years distant is no picnic. Spectroscopy, a method that studies the transmission of light from a planet's parent star through its atmosphere, is used in this process. The makeup of the atmosphere can be deduced by analyzing the distinctive fingerprint created when various molecules absorb light at different wavelengths. James Webb Space Telescope's infrared capabilities were important in these findings. Many chemicals that were previously difficult to identify are now within reach, thanks to the mid-infrared instruments. Expanded wavelength range, scientists are wondering what kinds of life could live in K28b's atmosphere because of the abundance of methane and the absence of ammonia. Since biological processes on Earth frequently result in methane, the discovery of this gas on K218b raises the intriguing prospect of hitherto unseen life forms adapted to a hydrogen-rich environment. Additionally, a subsurface ocean may be present based on the atmospheric composition position of K218b. This gives rise to intriguing inquiries on the dynamics of the atmosphere-ocean interactions and their potential impact on the habitability of the planet as a whole. Are we going to learn anything new about habitability and extraterrestrial life from its atmosphere? Typical Earth-like settings come to mind when we consider the possibility of life. Nonetheless, we have found evidence of life on Earth in previously unimaginable locations, exploring extremophiles, organisms that flourish in harsh conditions, can shed light on potential extraterrestrial life. Hydrothermal vents located deep within Earth's seas erupt hot water that is rich in minerals, forming an ecosystem that is both dark and brimming with life. Their thermophiles and acidophiles flourish, casting doubt on our long-held assumptions about the conditions necessary for life. Do you think exoplanets like K218b might be home to life like this? Unique circumstances for hitherto undiscovered life forms exist in K28b's hydrogen-rich atmosphere. Methanogens, a type of microorganism that thrives in oxygen-depleted settings and produces methane on Earth, might thrive in this atmosphere if the methane in K2 to 18b's atmosphere is biologically created from the corrosive Rio Tinto rivers in Spain to the Siberian tundras. The study of extremophiles broadens our knowledge of the circumstances that can support life. The fact that life may be found on Earth in such a broad range of harsh conditions makes us reevaluate the ecological boundaries of life beyond Earth as a possible exoplanet with a hydrogen-rich atmosphere and an ocean beneath its surface. K218b is a prime candidate for extreme life investigation. Maybe this faraway planet is home to a different kind of extreme life, one that has evolved to thrive in its own peculiar environment. What could the evolutionary history of extremophiles on K2118b be like? Complex life on Earth developed from simpler forms that lived as single cells. Is it possible that under ideal circumstances, a comparable process may take place on Other planets' dimethyl sulfide DMS could be present in K28b's atmosphere, which is one of the most intriguing things about studying it. This chemical, which could be a biosignature, is regularly made by phytoplankton on Earth, does its existence on K218b and other exoplanets suggest the possibility of life after being oxidized in the atmosphere. DMS contributes to cloud formation in Earth's oceans. The discovery of life beyond Earth may hinge on its existence in an exoplanet atmosphere similar to K218b. We are still in the process of testing K218b for the possible detection of DMS, although such complicated compounds can be detected by the JWST mid-infrared instrument. Their presence must be confirmed by meticulous investigation, and expert opinion. Scientists are ecstatic about the potential bio-signatures found on K218b like DMS. Nevertheless, it has also ignited a controversy, as is typical with any revolutionary finding. What DMS means for K218b is a contentious topic among scientists. Some see it as a promising biosignature candidate, while others point out that molecules with comparable structures can be generated by abiotic processes as well. The difficulty and complexity of deciphering extraterrestrial data is highlighted by this discussion. Skepticism has frequently greeted astronomical discoveries throughout history. At first, many people didn't believe Galileo when he said that Jupiter had satellites. There was also hesitancy when the first exoplanet was found in 1995. The importance of skepticism in the scientific process is highlighted by these historical examples. No one chemical or observation is crucial to the hunt for alien life. Researchers are on the lookout for biosignatures that, when combined, might provide strong proof of life. Is it possible that DMS, along with other biosignatures such as methane and water vapor, forms a bigger picture until further information is gathered? The discussion is likely to go on the proof that DMS is a genuine biosignature may be forthcoming from future miss with even more sensitive instruments, provided that technology continues to progress. Does DMS hold the secret to finding extraterrestrial life, or is it just a diversion? Regardless of your stance, the ongoing discussion highlights how science is dynamic. Our knowledge of K218b and other exoplanets has been greatly enhanced by the James Webb Space Telescope, but this is only the beginning of space exploration, a long and winding road. How will technology develop in the future, and what lies beyond this massive endeavor to broaden our understanding of the universe? Another revolutionary project is the extremely large telescope, which is expected to be finished by 2025. The world's largest near-infrared optical telescope with a main mirror diameter of 128 foot will be revealed. Signatures found by the James Webb Space Telescope may be confirmed or disproven by its unparalleled sensitivity. Finding from James Webb could be supplemented by data from another forthcoming mission, the Large UV Optical Infrared Surveyor LIRE. With its versatile operating wavelengths, LIRE has the ability to acquire direct pictures of exoplanets and conduct more in-depth atmosphere assessments. Propulsion technology advancements are crucial as we aim for farther away exoplanets. Ion propulsion and other possible approaches, incorporating antimatter propulsion, could allow probes to explore exoplanet planets within a human lifetime by substantially reducing travel times. We have an earlier video that discusses the potential and difficulties of interstellar travel. We should pause to think about the philosophical ramifications of our search for alien life, as we are on the cusp of perhaps game-changing discoveries. How does this journey impact our comprehension of the universe, and what kinds of concerns does it raise about what lies ahead anew? Mystery is the function of red dwarfs. Throughout the cosmos, these frequently ignored stars are the potential birthplaces of all life. They are intriguing hosts for planets that could support life because of their stability and durability. We would be confirming the presence of life beyond Earth and suggesting that the basic blocks of life are more universal than we formerly assumed. If we found extraterrestrial, plankton, or other kinds of life on planets like K218b, what mysteries will the coming decade unveil? Will we find more complicated mysteries that test our cosmic knowledge? Or would we prove the presence of alien life as we continue to push the boundaries of space exploration? The discovery of exoplanets like K218b opens up new avenues for understanding the vastness and diversity of potential habitats across the universe. The fact that we are now able to study exoplanet atmospheres in such detail marks a turning point in our search for extraterrestrial life. The combination of advanced instruments such as the James Webb Space Telescope JWST and future missions like Lyre and ELT will only enhance our ability to identify and analyze distant planets, possibly leading to the discovery of more planets with conditions suitable for life. These advancements in space exploration not only provide exciting prospects for the search for life, but